This is number 12 on your final review from Chapter 6. It says a baseball player throws a ball with an initial velocity of 140 feet per second at an angle of 22 degrees to the horizontal, and the ball leaves the player's hand at a height of 5 feet. Write the parametric equation. Well, we know it's not going to be a linear one because gravity's going to affect it. So we know we're going to have to use these equations, which will be given to you on your exam. So remember, VI stands for your initial velocity, theta stands for your angle, T stands for time, X sub I stands for your initial horizontal distance, B sub I again is initial velocity, H sub I is your initial height. So when I'm writing this equation, you're going to use what's given to you up here. Remember, my X represents my horizontal distance from left to right. So when I write that equation, I'm going to get X equals V sub I, well, that's my initial velocity, which I was told was 140 feet per second, times my cosine of my angle, well, my angle is 22 degrees, times it by T, which is time. In this case, our time is in seconds because it says per second. And then I don't have an initial horizontal value, so you could either put plus 0 or you could ignore it. Then I'm going to write my equation that tells me my height in terms of time. So when I do that, I will get y equals negative 16 times t squared plus my initial velocity was 140 sine of 22 degrees t plus my initial height. Well, they said the ball leaves the player's hand at a height of 5 feet, so that'll be plus 5. So that's how you get your two equations. Then it says find the ball's maximum height. Well, since we're talking about height, we know that's up and down, so we know that's our y equation that's going to come into play. So we're going to look at this first equation. So if I were to do a rough sketch of that, remember it's our height, which is y, in terms of our time, t in seconds. So we know it would be some kind of quadratic because I have t squared. So when it says maximum height, I'm looking for what we call the vertex. Well, our equation's in standard form. There's one way to get your vertex. It's you do the opposite of b divided by 2a. That gives you your x value. And then you plug in negative b over 2a into your function, and it gets you your y value. Well, in our first thing here, instead of x, it's y or t. So this will give us our time. And then once I plug that back in, it'll give me my height. So if I go and do that, from my original equation, which is up here, I'm going to go t equals the opposite of b. Well, my b is 140 sine of 22. So I'm going to do the opposite of that. So that'll be negative 140 sine of 22 degrees divided by 2 times a. Well, my a is negative 16. So then you'll type that into your calculator. One thing you do have to make sure when you're doing your calculator is that your mode is in degrees. So I'm going to go mode degree and then just type that in. So I get, and if you're typing it all in, you want the entire top to be in parentheses because that entire top is being divided by negative 32. So then I get sine 22 divided by negative 32 because 2 times negative 16 is negative 32. And you get about 1.6 seconds. Because remember, that was our t. Well, that didn't answer my question. I wanted the ball's maximum height. I found the time that the ball's at its maximum height. So after 1.6 seconds, I know it's going to be at its max height. So to get my max height, I'm going to plug that back into my original equation. So I'm looking for my y, my height. So I'll get negative 16 times t. T is 1.6. And square it. Plus 140 sine of 22 times 1.6 plus 5. And then again, just type this into your calculator. So I have negative 16. My t was, and if you want it exact, you can take that by going second answer. And then plus 140 sine of 22 times my answer, and then plus 5. And I get a height, a maximum height of, and if you round this, it's going to be a maximum height of 48 feet. So my maximum height for part B is 48 feet. Then to do part C, it says, how long is the ball in the air? Okay, so I'm looking for a time. Well, it would be great if I could use this equation, my x, because that tells me how long it goes. So how long it is in the air would be when it hits here. But I don't know the time. And I don't know how long it's in the air for. So how horizontal distance it is. So I can't use this equation. What I can use, though, is the y. Because if we think about it, how long the ball's in the air, we know if we look at that y equation, it's going to travel and then hit. We know the time is what we're looking for when it hits the ground. You're probably thinking, how does that help us? Because we still need to know our y value, or our height. Well, think about it. When it finally hits the ground, what is our height? Well, our height's 0. So I can use my y equation and plug my height in as 0. And then you're just left with a quadratic. So to solve this, we want to solve for time, because we want to know how long the ball is in the air for. Well, our time when it hits the ground will tell us how long it was in the air. So to solve this, we're going to use the quadratic formula. So you'll get, instead of x equals, it'll be t equals opposite of b plus or minus the square root of b squared, which is all of this, minus 4 times a times c divided by 2 times a. And then to type that into your calculator, you have to be really careful. So if I'm typing it all in, I know this entire top has to be in parentheses. So I'm going to go, negative 140. Oh, and actually I would have screwed this up. Because the opposite of b, well, this whole thing's b, so this should have sine of 22 in there. Sorry. Negative 140, sine of 22. I'm going to do the plus first. Square root. All of this is going to be squared, so 140 sine of 22 squared minus 4 times negative 16 times 5, and my parentheses. So that's my entire top. I'm going to divide it all by negative 32. Well, when I do that, I get t is equal to negative 0.09 seconds. Well, we know that's not going to work because negative seconds, that's before we even started. So then we're going to do it one more time. You could retype this all in, or you can do second enter, and then scroll back, and the only thing we have to change is our plus to a minus. And then I get t is equal to 3.37. So that means the time it traveled until it had a height of 0 was 3.37 seconds. That means the ball was in the air for 3.37 seconds. Then the last part. How far does the ball actually travel? That's talking about horizontal distance. How far did my horizontal go? Well, to figure that out, I can use my horizontal equation, because I now know how long it was in the air. So I know when it stopped being in the air. 3.37 seconds. So if I want to use my horizontal equation, I'm going to fold this for a second. My horizontal equation was x equals 140 cosine of 22 times our time. Well, remember our time, it's in the air for 3.37 seconds. And then you just plug that into your calculator. So 140 cosine of 22 times 3.37, and you get 437.4 feet. So the ball traveled 437.4 feet in 3.37 seconds. So that's how you do these parametric equations. You really just got to think about, is it talking about your horizontal or your vertical? And if it's asking for how long a ball was in the air, usually we set our height equal to 0 because that's when it lands. And that's the stopping point for it being in the air. So that's how you do this one. Any more questions, let me know. Happy studying for your finals.